Welcome back, AI Paper Podcast. Today, we're diving into a paper that tackles a challenge. You've probably encountered this in your work, right? Reading text from videos.
Yeah.
We're talking, news tickers, subtitles, even text on clothing in like a fast-paced action scene.
That's right. It's all about OCR, optical character recognition, but with a twist.
Okay.
This paper explores how vision language models, those powerful AI systems that can process both images and text, they're shaking up the OCR game.
For those of you just joining us for the short form edit, here's the key takeaway. This paper introduces a new benchmark dataset specifically designed to evaluate how well VLMs perform on real-world OCR tasks in videos. The researchers pitted three leading VLMs, Anthropic's Claude 3, Google's Gemini 1.5 Pro, and OpenAI's GPT-4o, against traditional computer vision OCR systems like EasyOCR and RapidOCR. The results: VLMs demonstrated superior performance, particularly in handling complex scenarios like moving text and unusual fonts, but they still face challenges like content security policies that can hinder their reliability. Now, for our deep dive listeners, let's unpack this further. Before we jump into the specifics of this paper, can you give us a quick refresher on the differences between traditional OCR and how these VLMs approach the problem?
Absolutely. Traditional OCR relies on a two-step process. First, it identifies where the text is located in the image. Think of it like drawing bounding boxes around each word. Then it tries to recognize the characters within those boxes.
So it's like teaching a computer to see and read separately.
Exactly. But VLMs change the game entirely. They process visual and textual information together, allowing them to leverage context and understand the relationship between images and words in a way that traditional systems just can't.
Okay, so instead of just looking at pixels, they're understanding the meaning behind the visuals?
Yeah.
So how did the researchers in this paper go about putting these VLMs to the test?
They created a new data set of 1,477 manually annotated video frames, specifically designed to challenge these models.
Okay.
They didn't just grab random snippets, they carefully selected frames from a diverse range of domains.
What kind of domains are we talking about? Give us some examples.
Think about the variety of videos you see online. They included frames from news broadcasts with fast-moving tickers, YouTube videos with handwritten notes, code editors with different fonts and syntax highlighting, advertisements with stylized text, and even online lectures with subtitles. They wanted to cover as many real-world scenarios as possible.
That's quite a mix. It sounds like they really wanted to push these models to their limits and see how they handle different fonts, backgrounds, and text styles, and even languages.
Exactly. The goal was to evaluate not just accuracy, but also robustness and real-world applicability.
Okay.
Can these models handle the messy, unpredictable nature of video content?
Okay, so they've got this diverse data set. They've got their lineup of cutting-edge VLMs and traditional OCR systems. What did they find? Which model came out on top?
Based on overall accuracy, GPT-4o took the crown, but Gemini 1.5 Pro had the lowest word error rate. They each had their own strengths.
Interesting. So different strengths depending on the metric you're prioritizing. But let's get back to those traditional OCR systems. You said they included EasyOCR and RapidOCR in this benchmark. How did they fare against the VLMs?
Honestly, not so well. Both EasyOCR and RapidOCR lagged significantly behind the VLMs, particularly when dealing with complex scenarios like moving text or unusual fonts.
So even though traditional OCR has been around for a while, it seems like VLMs are poised to really shake things up.
Absolutely. They're demonstrating a level of accuracy and adaptability that traditional methods just can't match.
But before we get too carried away praising VLMs, you mentioned earlier that they're not perfect. What are some of the limitations that the researchers uncovered?
Well, beyond just looking at the raw numbers, they dove into some qualitative examples to see where these models tripped up. And what they found is that even though VLMs generally outperform traditional methods, they still struggle with things like noisy backgrounds, unusual fonts, or partially obscured text.
So context can still be a challenge, even with these advanced models. It's like we're peeking under the hood and seeing the gears turning, trying to figure out how they're making these decisions.
Right. It's not enough to know that a model gets something wrong. We need to understand why it made that mistake.
Yeah.
That's where the real insights lie.
Okay, I'm definitely curious to hear about some of those insights. What kind of mistakes were these models making? Were there any particularly interesting, or dare I say hilarious examples?
Oh, there were definitely a few that made me chuckle. For example, in one case, the models were trying to decipher text from a video with handwritten notes. The ground truth was base direction and SETI, likely shorthand for safety. But the models got a bit creative, Claude interpreted base as baseline, while GPT-4o decided it meant base uses, and Gemini went with baseline.
It's like they were trying to fill in the blanks based on what they thought should be there.
Exactly. It highlights this fascinating tendency for VLMs to try to overcompensate or correct things that don't necessarily need fixing.
You know, you mentioned that Gemini 1.5 Pro had the lowest word error rate overall. But did the researchers notice any specific areas where it struggled compared to the other models?
Yes, actually, they found that Gemini had a particularly tough time with financial content, like stock tickers or news graphics. Its accuracy dropped significantly in that domain compared to GPT-4o and Claude.
That's really interesting. So it's not just about overall performance. It's about understanding the strengths and weaknesses of each model for specific tasks.
Absolutely. And that leads us to another crucial consideration when it comes to VLMs: content security policies.
Ah, yes, the elephant in the room. Can you explain that a bit more for our listeners? What are content security policies, and why are they such a big deal for VLMs?
Content security policies are essentially safeguards built into these models to prevent them from being used for malicious purposes.
Okay.
They're designed to filter out content that might be harmful, offensive, or illegal.
So it's like a safety net to prevent the AI from going rogue.
Yeah.
But you said these policies can sometimes be a problem.
The challenge is that these policies can be overly sensitive. Sometimes they block content that's perfectly harmless just because it triggers certain keywords or patterns.
So you're saying that even if a VLM is capable of accurately reading text from a video, it might refuse to produce any output because of these security measures?
Exactly. And that unreliability can be a real headache for developers who are trying to use these models in practical applications. Imagine you're building a system to automatically generate subtitles for videos. Everything works perfectly in testing, but then in the real world, the VLM starts randomly refusing to process certain videos because of some overly cautious content security policy.
That would be incredibly frustrating. It sounds like a major roadblock for real-world adoption.
It definitely is a concern, but it's important to remember that this is still a relatively new field. As VLMs mature, we can expect these security policies to become more sophisticated and nuanced, reducing the likelihood of false positives.
That's good to hear. It sounds like there's a lot of potential for improvement on that front.
Absolutely. Now, before we move on, I wanted to circle back to something you mentioned earlier about understanding why VLMs make certain mistakes. The researchers provided some fascinating qualitative examples in the paper that really shed light on this.
Yes, let's dive into those. You were telling us about how these models sometimes try to correct things that don't need fixing. Do you have any other examples of that?
There's one that really stood out to me. They showed a frame from a TG commercial with the text, "Trader Joe's Organic Reduced Fat Sea Conyu CNBC." It's a bit messy, but you can clearly see the brand name, the product description, and the news channel logo in the background.
Okay, so there's some context there, but it's not a perfectly clean text extraction.
Right.
What do the VLMs do with that?
Well, Claude decided to add coconut milk after reduced fat, even though that wasn't in the original text.
So it was trying to be helpful by filling in what it thought was missing information, but it ended up being inaccurate.
Exactly. It's like it was relying on its knowledge of Trader Joe's products to make an educated guess, but it missed the mark.
What about the other models? Did they fall into the same trap?
Gemini played it safe and kept things more literal, preserving the truncated CNU from the ground truth. But GPT-4o, in its quest for accuracy, replaced CConU with coconut.
So it recognized that QNU was likely short for coconut, but in doing so, it actually diverged from the ground truth. It's like it overthought the problem.
Precisely. It shows that these models are still learning the fine line between correction and faithful transcription. They need to understand when to stick to the literal text and when to apply their knowledge to fill in the gaps.
It's fascinating to see how these different models approach the same problem in such distinct ways. It really highlights the complexities of building AI systems that can understand and interpret the nuances of human language and visual information.
Absolutely. These qualitative examples provide a valuable window into the inner workings of these models and help us identify areas for improvement.
This deep dive has certainly given me a new appreciation for the challenges and opportunities in the field of OCR, especially with the rise of VLMs.
Me too. It's clear that VLMs have the potential to revolutionize how we approach OCR in videos. They're more accurate, more adaptable, and better able to handle complex scenarios than traditional methods. but there are still hurdles to overcome, like those content security policies we discussed.
Yes, those policies are a real concern, but it sounds like there's optimism that they'll improve as the technology matures.
Exactly. It's all about finding that balance between safety and functionality. We need to ensure these models are used responsibly without stifling their potential.
Well, before we wrap up this part of our deep dive, I wanted to shift gears slightly and talk about the broader implications of VLMs beyond OCR. This paper focused specifically on reading text from videos, but these models have the potential to go so much further.
You're absolutely right. We're just scratching the surface of what VLMs are capable of. Think about all the tasks involved in truly understanding video content, identifying objects, analyzing scenes, recognizing emotions, even predicting what might happen next.
It's like giving AI true visual literacy, not just the ability to decode letters and words. What are some of the exciting possibilities that you see on the horizon for VLMs in video understanding?
The potential applications are mind-boggling. We've already touched on content moderation, but imagine VLMs that can analyze video in real time, not just for inappropriate content, but for specific objects, action, or even emotions.
It's like giving AI true visual literacy, not just the ability to decode letters and words. What are some of the exciting possibilities that you see on the horizon for VLMs in video understanding?
You could have systems that automatically flag videos for copyright infringement, detect violent or dangerous situations, or even analyze customer reactions to products and marketing campaigns.
And it's not just about analyzing existing content. VLMs could also revolutionize video creation. Imagine AI-powered editing tools that understand the narrative structure of your footage, suggest cuts and transitions, or even generate special effects based on your creative vision.
That's an area I'm particularly excited about. We're already seeing early examples of this with AI-generated music and art, but imagine applying those same principles to video. It could democratize filmmaking and empower anyone to tell their stories in visually compelling ways.
It sounds like we're on the verge of a creative revolution powered by VLMs. But let's not forget about the practical applications as well. You mentioned accessibility earlier. How could VLMs help make video content more accessible for people with disabilities?
This is an area where VLMs could have a truly transformative impact. Imagine VLMs that can generate detailed audio descriptions for visually impaired viewers, providing a richer and more immersive experience than traditional audio descriptions.
That would be incredible. It would open up a whole world of video content that was previously inaccessible.
And it's not just about audio descriptions. VLMs could also be used to translate sign language in real time, breaking down communication barriers and fostering greater inclusivity.
The possibilities are truly endless. It's exciting to think about how VLMs could change the way we create, consume, and interact with video content in the years to come. But with any powerful technology, there are also ethical considerations to keep in mind.
Absolutely. As VLMs become more sophisticated, we need to be mindful of potential biases in their training data. We need to ensure that these models are developed and deployed in a way that promotes fairness, accuracy, and respect for privacy.
It's a reminder that technological advancements should always go hand in hand with thoughtful consideration of their societal impact. It's not just about what we can do with VLMs, but what we should do.
Exactly. We need to have these conversations now to ensure that VLMs are used for good, to enhance our lives, and to create a more inclusive and accessible future.
Well said. So to wrap things up, what are your key takeaways for our listeners who are working in this field or who are simply fascinated by the potential of AI?
I think the biggest takeaway is that VLMs are rapidly changing the landscape of OCR and video understanding. They offer a powerful new set of tools for analyzing, creating, and interacting with video content. But it's crucial to be aware of both their strengths and limitations, as well as the ethical considerations that come with any powerful technology.
This has been a fascinating deep dive into the world of VLMs and OCR. Thanks for joining us on this journey, and be sure to check out the show notes for links to the paper and other resources. Until next time.